Okay, so today is all on derivatives, but it's no application. That's all Wednesday. So today is just rules, your derivative rules, okay? Yep. All right, so here we go. We're looking at number 3. It's given me e to the negative, is that an x squared? Okay, and it wants y double prime of 0. That means how many derivatives are we going? Okay, and then when we're done, we're going to shove in a 0. Okay, so think of your rules. Okay, so taking if he's y prime is going to be what? Yep, leave it alone. Times the derivative of the up, negative 2x, times ln of the base, but ln of e is just 1, so we can skip that part. Okay, so now we're here. Can I clean that up in any way, shape, or form? Not really. So now let's go y double prime. What do we have now? We have a product rule. So I'm going to look at this as one guy, and that's another guy. Okay. Product rule. You want to go derivative and then leave it, or leave it and derivative? Leave it. Okay, so leave it, derivative, plus derivative times the derivative of the up times natural log of the base, which is just 1, times the leave it, negative 2x. Everybody good? Don't just write it down. Think through it. Okay, so now let's clean. I've got an island right here. So negative 2 e to the negative x squared, just to make it look somewhat normal. Then is the second island back here going to be positive or negative? It's positive, so plus 4x squared e to the... Okay, now that's y double prime. But now what does it want me to do? Plug in a 0. So negative 2 e to the 0 is 1, right? So that's just a negative 2. Plus 4 times 0. 0's going to wipe this whole back term out, isn't he? So what's your answer? Done. Next, number 5.
Oh my.
Number 5 is neat. We didn't do any like number 5, but it's really, really cool. And Barron really, really likes these. So number 5 says, if h of x equals g of f of x, then h prime of 3 equals something. Go back to the page before it. Do you see this big old table right here? It says for questions 4 and 5, use the table. Well, look, it's giving me f, f prime, g, and g prime at all these different x's. So all it's asking me to do is follow the derivative formula literally. So if h of x equals g of f of x, I need to find h prime, which means I need to take the derivative of this. What kind of rule is that? That's your chain rule. Quit looking at the chart. Stay right here. Let's do the derivative of this. So what would you do? Derivative of the outside. Take the derivative of the outside and times it by the derivative of the inside. Do you see what I'm like this? It's very theoretical. It's not like you don't know what the function is. Everybody okay with what we've just done? Now, at where? Okay, so now watch. G prime f of 3 times f prime of 3. All I've done is put a 3 in where my x's are. Okay, let's go find this piece right here. So go flip over to your chart. Now, this wasn't f prime, this was just f. F of 3 is what? Okay. So I have g prime of 4. Everybody see what I'm doing? Now I need what? F prime of 3. So f prime of 3 is 2. Now what do I need? G prime of 4. G prime of 4 is a half. Answer? 1. Y'all good with that? There'll be some more of those that'll pop up and you'll get better at them. Is everybody okay with going from here to there? Again, that's just your rule. All right, Miss Kenya, where are we headed? Number 7. Okay, if y equals that over that, then dy dx. So it wants the derivative. What, this is our low-d high. Okay, are we ready? Low, what you got? D high. Love that. Minus high D low. -5. Over 2 minus 5x squared. Now, if you look at your answers, don't all the bottoms have a 2 minus 5x squared? That's not where I need to focus. I need to focus on the top. So go clean the top for me. I got a -13. Answer? Oh, we're done with this one? All right, Barron's 2. Barron's 2, number 3. Tanner. Less of that. In fact, none of that. All right, here we go. Number 3. Rule. What? What's the rule here? Look at the whole thing. Yeah. It's a quotient, isn't it? So this is low D high. Y'all are focused on the top. You got to look at the whole thing. You can't L'Hopital's rule this. This is not a limit. You've got to, this is full out low D high, high D low. Okay, so low, D high. Leave it. Derivative of the top. Okay, or the upper. Okay, so derivative of ln of u. That's a log. Of over of. So derivative of the of over the of. And then technically ln of the base, which is e, and so that's just a 1. Okay, so that's your low D high. Minus high D low over u squared. Okay, clean up that first little island. Yeah. The u and the 1 over u going to cancel, so E ln of u minus E ln of u over u squared. What happens to the top? You get a 0. Yeah. And that's okay, right? 0 on the bottom is not okay. 0 on the top is okay. 0 can happen, just not on the bottom. All right, Kenya. Number 6. Do y'all see what I mean about these being like straightforward, to the point, follow your rules? It's a really good brush up on our rules. Okay, speaking of, what rule is that? That's your chain rule. Do you remember when I taught this and you got all confused and I said, okay, when it's a trig function to a power, think about it like that. Do y'all remember that? So the 3, this is the power rule. The 3 is going to come out front, all the crap in the middle, and then to the second. And then you got to do the derivative of the inside, which is a chain rule all by itself. So this is a chain. Got it? Okay, so here we go. What do we got? 3 times. Okay, now ignore the 3 and just do the derivative. Okay, so what's the derivative of sine? Cosine of the inside, leave it alone, times the derivative of the inside. Okay, so I have this, which is all linked together. I have this, which is all linked together. And I have the straggler -2 and this 3 in the front. That's going to give me a -6. Then I got a sine squared 1 minus 2x and a cosine of 1 minus 2x. Who are we looking at? D. Do everybody see the chain within the chain? Okay. 7. All right, dy dx. What kind of rule? Product. Okay, you try it. I'm going to work it out too. You try it without me saying anything. Can't read that. Nobody's whipping out any logs, are they? Because that's the antiderivative of 1 over x. 1 over x is just x to the -1. So you'd pop the -1 down front and take 1 from his power. Y'all cool with that? So I did the derivative and then leave it, plus leave it, and then the derivative, which is leave it, and then the derivative of the up, and then ln of the base, which is just 1. Okay. So he's pretty well done. Plus, let's see. That x to the -2 and that x to the 2, aren't they going to cancel? And then that -1 is really just going to make this a minus e to the 1 over x. Okay. I'm not seeing that as an answer. I see 2 answers that have pulled, well, 3 answers that have pulled an e out.
You pull it out, 2x minus 1.
2x minus 1, do y'all agree? Y'all liking B? Okay. Guys, is everybody okay on the green box? Everybody see what I boxed in green? Everybody's cool? With a 1 over x especially? Okay, awesome. Where are we headed? 36. Okay. 36, it says use the graph of f shown on 0 to 7 for questions 36 and 7. Let g of x equal the integral from 2 to 3x minus 1 f of t dt. 36 says find me g prime of 1. Do you remember at the in the very top line up there above the graph at the very end? Do y'all see the variable in your your lower limit to your upper limit? Does everybody see the 3x minus 1? Does anybody remember what we did with that? We took him and put him in here and then times him by his derivative. It wasn't that long ago, but it was one of those small little things. It's like, oh yeah, sure, got it. And it didn't stick with us because we got it too easy and we never used it on anything. So take your upper limit and he becomes your f of x. And then times that by the derivative of what you just plugged in, which is, and now what? Thanks, Hope, for your words of guidance. You're going to plug in a what? A 1. So 6. Yeah. Maybe star that problem. Not that you just need to go back and listen to that one again. Because it's not that it's difficult. It's the, oh, what do we do? It's that kind of thing. All right, where are we headed? 40. Oh, this is another good one. This is another one like the table, but it doesn't have a table. It just gives it to you in a big string of mess. Suppose f of 3 is 2, f prime of 3 is 5, and f double prime of 3 is negative 2. They're giving you all the information that you're going to need in a minute. What you need to focus on is I want the double derivative of f squared. Whatever the function is, he's squared. So how do I find the derivative of something squared? Okay, so what do you got? 2 f of x, technically to the first, right, because you take a power off, times the derivative of f of x. It's the chain rule. You pull your 2 down front, leave the function alone, drop your power 1, and then do the derivative of the inside. So that's what I got, and I want this to happen where? At where? Well, technically I need to go again, don't I? All right, let's go again. Now, if I go again, what have I got? What rule? Product rule. Now, you can sort of attach the 2 to the f of x, or you can sit the 2 out front and just let him chill while you do your product rule, and then pull him in at the very end, which is what I'm going to do. So I'm going to look at f of x times f prime of x. Okay, so go product rule on him. Okay, so leave it. Derivative, so f double prime of x plus f prime times f prime. Okay, so I got my 2. He's chilling. Now I'm plugging in a 3. So guys, I'm plugging in a 3 here and here and here and here. So what's f of 3? Okay, so 2 times. What's f double prime of 3? No, f double prime of 3. That's okay. Negative 2. Plus, what's f prime of 3? And then what's f prime of 3? So 2 times negative 4 plus 25. Negative 4 and 25 would be 21. 21 times 2, 42. Do you see how that one follows the one that had the table?
So once we do the second derivative, then we start putting the numbers.
Yes, once you've gone as far as they want you to go, then you shove numbers in. And they should have given you enough information to find all your pieces. Y'all were cruising.
Oh, baby. I just didn't sleep good at all. I'm missing that. Oh, yeah.
Okay. What number? Oh, gracious. How many derivatives are we going? Okay, what have we got? We're on Barron's 3, baby. Go golden. Okay. Oh. Okay. Leave it. Derivative. The log. Dov over of ln to the base. That's gone. Plus derivative 1 and then leave it. Okay. Now clean. Might as well. Okay. That's y prime. I would label it so you can keep up with how many because we got to go 3. Okay. So now I'm going y double prime. Okay. What's the derivative of 1? 0. What's the derivative of ln of x? Good. So now we're here. Which is really x to the negative 1, right? Okay, because I'm about to go power rule on this sucker. Triple prime. Pull your power out front. Knock it down 1. Now what? Plug in an e. So negative 1 over b squared. C. Okay, where are we headed? 23.
Hey, Matt.
Nope.
Oh, wait.
Yep. No, I would never say that. I meant, yes, Tanner, what's your question? 23. Okay, we're going one derivative. That's ln of a big old hunk of. Okay, dov over of. So you need to go dov on that, which is a quotient rule. Think of the bottom as x squared plus 1 to the 1/2, okay? So low d high. 23. Okay, so there's your low times your high, or d of the high, so 1, plus, minus, oh, thank you, minus, you wrote a plus. All right, high. All right, now d of the low, this is a power rule with a chain in it, right? So kick the 1/2 out, leave the insides, knock 1 off your power, and then derivative of the inside. Over. Low d high, high d low, over low low. Can you just do x squared plus 1? Because he's rooted in, you're going to square him so it goes away. Now, that's dove. You haven't done the over of part yet. So do you guys see, you've got to keep track of what your big picture is, or you'll lose the structure of the problem. Over. One half. Okay, so there's your dove over of. Everybody good with that? Now what? Can I both?
Because all your answer choices at X times.
Oh, you know what? I have another strategy. God, we did the same thing when we learned this back in the day. These are logs, right? Don't logs have properties? Properties that could maybe make division not division.
Oh, we could have done subtraction.
And looking at this, which we're about to Bojangles and then GCF and then move and all this stuff, I'm backing it up. Yep. Nope, backing it up.
Go ahead, mark out A and D. Right, sir. They weren't going to be an option.
How do you know?
Well,
I don't.
when you do a little Bojangles action, you even have never mind.
All right, ln of x minus ln of x squared plus 1 to the 1/2. What do you do with powers?
Kick it out front.
Now I'm just going to do the derivative of this, just very nice and sweet. Okay, so ln of x, that's of over of. Have y'all started to sort of put this together that, oh yeah, it makes sense that it's 1 over x because the antiderivative of 1 over x is ln of x? Okay. Minus 1/2 is chilling. He's a constant sitting in the front. Okay, now what do you got? Dov over of. Little 2's can cancel, can't they? So now I have 1 over x minus x over x squared plus 1. They do. They both need what the other one has. Everybody agree with that? So the first guy's getting an x squared plus 1, and the last guy's getting an x. Okay. Cross out your x squareds. So I have 1 over x squared plus 1. So which one are we going with? B.
Oh, how am I wrong?
Listen, I can't remember which one she said.
Okay. Where are we headed, Kenya? Princeton. Gotcha. Okay, one derivative. You do it. One derivative and plug it in. I got 40/3. Everybody good? All right, Miss Kenya. Number 3. Okay. One derivative. No logs. I can't use like my log properties. This is, I got to do a what? Quotient rule. So go low-de high, high-de low on this guy. And focus on your cleaning. Oh, I lost it. Right there. There we go. Okay, I'm here. Did y'all get here? It's not an answer choice. Anybody see anything we can do? An X. Do y'all see that? Do y'all see how we can GCF an X out of the bottom? Okay, but hold on, because the whole bottom is being squared. So technically, like if I have this, if I just had this, I'd do this, right? Right? Okay, but what I have is that. So does he come out as an X? He comes out as an X squared, because the whole enchilada is being squared. So I have that, and then those little guys can cancel. And now we're looking at C. Do you see how they're going to take and I call it simple, a simple quotient rule and put just this little twist in it? Okay, where are we going? Number 5. Okay, now this is our first one of these in a long time. Anybody remember what this is called? I'm taking the derivative, but he has x's and y's in him. Starts with an I. Implicit. This is implicit differentiation. So we're going to take the derivative with respect to x. But when you have a y, after you take the derivative of something with a y in it, what do you have to put immediately after that? dy dx. Okay? So if I just have a little island and he just has an x on him, that's just 2x. That's easy peasy. Because I'm taking the derivative with respect to x. X's are normals. Y's are like visitors. They need this extra pass. Okay, now, I'm going to put my minus and my 2, and then I'm going to bracket this sucker off and just use the x and the y as what I'm doing my product rule on. Because I don't want to have to worry about my negative or my 2. I'm just going to leave him out and run him through later. Okay, so which way do y'all go? Do y'all leave it first? Okay, so leave it. All right, what's the derivative of y? Right, technically it's a 1, right? And then dy dx. Plus, okay, derivative, 1 times y. And he doesn't need a dy dx because I wasn't taking the derivative of the y. Close it. Plus 6y dy dx equals derivative of 8 is 0. Now it wants me to solve for dy dx. Okay. I'm going to distribute my 2 back through, okay? Do you see your terms that have a dy dx in them? How many of them are there? How many terms don't have a dy dx? Okay, so the guys that have a dy dx I'm going to keep. The guys that don't have a dy dx I'm going to move over. Okay, but we're smart kids. While I'm doing that, on this side that has the dy dx, I'm going to GCF the dy dx out of those two terms. Okay, so I've got this guy and this guy that are staying, but while they stay, I'm going to GCF my dy dx out. What does that leave me with? Equals, okay, now my two normal guys that I'm moving over, both their signs are going to change. So negative 2x plus 2y. This is very algebraic. Now what am I going to do? To solve for dy dx, divide by 2x plus 6y. Okay, now a choice. Can you take a 2 from everybody? It's kind of like GCFing a 2 and then canceling it out front. Or it's sort of like, okay, if they can all cheat with a 2, let them cheat. So that's going to give me negative x plus y over negative x plus 3y. All right, now I'm kind of looking like this guy, and I'm kind of looking like this guy. Let's see who's got the right signs. Oh, B's got the 3 in the wrong spot. All right, are we liking this guy? Y minus x, positive 3y minus x. Are we liking it? I like it. What was that called again? Implicit differentiation. It's when you have x's and y's together. Anytime you take the derivative of a y, just slap a dy dx behind him. All right, babe, where are we headed?
Number 7. I completely forgot I had it.
Oh, God, responsibility. Okay, I want the derivative. This is simple. It's 2 terms. You just got to remember your trig. What is the derivative of secant? Secant tangent. Do you remember me saying that secant and cosecant were conceited because they put themselves in their derivatives? So secant is going to be secant tangent. Cosecant starts with a C. So negative. Conceited. So cosecant. Cotangent? Yeah. And anything that we use today that's on your formula sheet is going to be on your formula sheet quiz on Wednesday. So all your derivative rules, including the trig, are for Wednesday, which we'll talk about. Yeah, that whole half, that whole top.
So it's going to be like,
I think so. Yeah. I might give you the front end. That's good times. All right, babe, where are we headed, Kenya? 10. Okay, I'm going to let y'all try this one. He's a double derivative. What rule are you using? Power rule with a chain. Then it becomes a product rule after that, doesn't it? Does everybody have that for their first one? Okay, I'm going to clean and pop the negative out with a 2 before I dive in. And I'm going to leave the negative 2 sitting out front and go product on just the cosine sign. Okay, I got here. Everybody get here? Now what am I doing? Plugging in a pi. Okay, pi is west. So what's cosine of west? But it's squared, so positive 1. And what's sine of west? 0 squared is 0. So negative 2. What? Where are you?
When you plug in pi?
Yep.
I thought it was.
It is the double angle formula. We don't need it though. Pi is here.
Oh, yeah.
That's all right. All right, where are we headed? 11. Okay, 11 has nothing to do with derivatives, but you remember the one last time that was just like crazy easy and it just needed to get thrown in somewhere? So here's this one. There are no derivatives in here, are there? No. I just want you to find g of f of 2. So where do you start? Plug in 2 in for f. Okay, so plug a 2 down there. 2 squared is 4. 4 plus 1 is 5. 5 over 5 is... Okay, now what do you do with the 1? Plug it into G, what do you get? So like if we get one like that on the AP exam, you get all kinds of excited. 20. What kind of rule? This is a product rule. It's a product rule with a chain and a power. Here we go. Product this guy times that guy. Okay, ready? Leave it. Right? Now what y'all do first? Leave it. Okay, now derivative of this. Now picture that to the 1/2. So pull your 1/2 down. Leave it. Is that a cube? Knock 1 off your power. And then you got to do the derivative of the inside, which would be, okay, that's just the first one. Plus, that was leave it, take the derivative. Now we got to take the derivative, leave it. Okay, now let's be smart. Isn't it asking it at a very specific number? So does it do me any good to clean this up? Like, I could screw that up. Just take this hideous mess. You're plugging in a 0. That's going to wipe out, like, everything up here. Like, he's gone. There's an 11. Here's a 1/2. He's gone. That's a 121 to the negative 1/2. 1/11 times he's gone 5. What? Isn't it? Isn't it the square root of 121? On the bottom. Who do what? Yes. Root him and move him. Plus, all right, he's gone. That's a 1. He's gone. That's a 121 to the positive 1/2, so that's a 11. These cancel, and that gives me 5/2 plus 11. Yeah, that's 22/2, so 27/2. Okay, y'all do it. That's a quick one. Pull the 3 up as a power. So it'd be 5 to the 3x ln of 125. I think. Everybody good? Okay. 26. Find an f prime of pi. Tell me what our rule is. Power rule with a chain. Go. That's a power? You thought it was a product? Yeah. I can't hear myself talk. These big headphones on with my Britney Spears microphone. Okay. Now, right here, guys, I almost got caught because I almost said, oh, okay, now I just got to do the derivative of x plus 1. But the 3 is, so now I got to do the derivative of cosine, which is negative sine, leave the of, then take the derivative of the of. And that's why putting that power way outside might help. Almost caught me on that one. All right, I'm not cleaning this up. I'm plugging in a pi. No, I'm not. Oh, yeah, I am. Well, yeah, okay. So negative in the 1, so negative 3 cosine squared pi plus 1 and a sine of pi plus 1. Bless you, bless you. What are we thinking? Hey, good. Can you get it? Oh, God. All right, 28. Just be crystal clear about your rules. The outside function is a natural log. So you're using that rule. So that's dov over of, right? Dov is the derivative of the inside. Okay, so how do you take the derivative of the inside? Dov over of. So what's dov? -1 over of. Okay, now technically that's the dov of the whole enchilada. Now that's got to be over the of. Little bojangles, which is just going to take the bottom and put it on the bottom. See? So we're yellow. How many we got in Princeton too?
1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay, number 1, go. See if we can pick the pace up just a smidge. Oh, every time. I got a -32. Okay, now yeah, this is another chain rule, but look at, I mean not chain, a quotient rule, but look at your answers. 3 out of the 4 of them, they just left them. So just go quotient rule on this guy, but don't clean anything up. Look at your 4. 64 over 8. It's okay. This one should be 1 step and done. Very important to pay attention to when you're taking the AP test also. Like, don't go spin your wheels cleaning this up when the multiple choice doesn't want you to. So make sure you look at your answers. What did we get? Everybody say D. 9. Oh, he's a good one. What's my rule? Product with a chain. Okay, so leave it. All right, derivative. Negative sign 2x times 2 plus 2x cosine 2x. Pull the 2 out here, so 2x squared and the negative. Sine of 2x plus 2x cosine of 2x. Ooh, I see double crap. Don't y'all see double crap? Oh, good. Yep, I see. But do y'all see a double angle formula creeping? It's creeping. Okay, what is he? Implicit. Implicit product? Is he product? Okay, again, keep your dy dx terms on the one side, move your non-dy dx terms on the other side, and suck out the dy dx while you're at it. I'm missing a, I don't know. That's a positive, isn't it? I'm right there. Okay, now, yeah, pull a negative out of the top, and it turns into what number? What letter? C. Announcements? Okay. I'm done. I'm done until 1st of May. All right, 19. Simple, easy, go. 19. Follow your rule. D. Oh, sure. Yeah, I pulled all kinds of test questions from these. Yep. 21. Are we headed to 21? Oh, triple. Oh, and you know what was creeping on the last problem? He walks in the door on this one. Okay, so this is a power rule, but remember there's a chain in here too, because you pull the power down front, knock your power down by 1, but now you have to take the derivative of the inside. So what's the derivative of sine? Remember what? No, not yet. No, we're not. Just keep going. You what? Yeah. Yeah, what would that turn him into? Sine of 2x. And then you'd have to go again. Well, you have to go again. Y'all, what do y'all want to do? Y'all want to make him sine of 2x? Want to try it? I did not. No. I caught him at the end. Okay, so that's one derivative. So this one's going to be the second derivative. So that's going to be cosine of 2x times 2. So that's the second derivative. Now to do the third derivative, see? So guess what that means it's going to be on your quiz on Wednesday. It's time. It's time. No, I don't care. Hey, stop. It's going to be there. You don't have to like it. Well, uh-huh. How many more do we have on this one?
See, 26, 33, 42.
Is there one of them starred?
33.
Let's do 33.
Good afternoon, George. Second day and practice today, and soccer will practice today in back camp. Softball games today has been canceled and moved to April 10th at home, and there'll be a doubleheader starting at 4. Classes, the order has to be yearbook for sports and
Okay, tell you what, we're running out of time. Give me my card. Okay. Are you ready? Do y'all want them, or do you want to just go look online? Okay. Number 33, put a star by him, because we're going to hold off and do that sucker together Wednesday. Okay, let's take a look at your formula sheet and let's see what you're going to be quizzed on. Okay, so on the back, everything above sea level. See the line? Everything above the equator.
And we need to go to the right.
Yeah, I'll give you left side of everything, right? I'm looking at derivatives, okay? Then flip on the front. Double angle formulas. I'm fine with giving you the sine of 2 theta, cosine of 2 theta, cosine of 2 theta, cosine. I'm fine with giving you the left-hand side. But you need to know all 4 of those. It's time. We fought it for almost 100 and some days now.
What if we broke it apart?
I'm thinking that you're still wearing.
The double angle formulas and the derivative, that's a lot of stuff. At least for me.